The study one of predictive analysis was based on simple linear regression analysis. The purpose of this study was to understand and build up a model that which are those features of car, either the external or the technical specification features, have a high influence on the car price, because that's the aim of a company was to identify and accordingly take decision, either the position a car in its particular car band, or to exclude, include, or tweak the features to be as good as any other company in the car market. So we have got a data point where 205 car models were there with its car prices and the features of it. How I did the first did the data cleaning of it, where looked at the error into the data in terms of spelling or some missing values, as well as some simple label, whether it's a numeric or character as a factor like that, and accordingly changed it. Then I did a first level of analysis, which is a univariate, used bar graph, used scatter plot for the continuous data to understand which are those individual features which has high impact or low impact, no impact on the car price. Then went ahead for building the model. But since it's a simple linear, I need to convert them into a numeric, all of this model into numeric and the continuous. So converted some of them as a dummy variables, some as a level variables, and continuous variables were kept as it is. So finally I got a data frame which was having close to 71 independent variables, and went ahead for building the model. Of course, this was removed, some of the columns were removed from the dummy variable which was not needed, and all of them are joined together. So the final data frame is what I'm talking about, which is 71 independent variable and one of my dependent variable, which is car price. Now I split the data 70% for the model building and the remaining for the test purpose. Since the number of features were more, I used step AIC to the first level of identifying which are the important variables to be kept in the model, and I was able to get 37 such variables. Then I used LM model and to keep on creating model one by one, used p-value and VIF value to take a decision. Of course, R square value to take a decision which variable to be kept in the model or to be removed, and reached to a situation where I had in a model which has R square 94%, all the variables p-value as 3 star and VIF as less than 2, but one of the features variables had more than 2, but I felt it is to be kept in because remove that, R square was reduced into 82%. Tested the model on my test data and found out again R square as 94%. So I concluded here that we'll go ahead with this model where I had 10 independent variables, and all other factors were pretty good, close to 94% in accuracy, and I feel this is pretty good model, feasible to do that, whether I do a 9 variable or 10, to better to keep 10 where I have high accuracy, where 94% of the car price has been explained by this independent variable. So I concluded my model at this place. Thank you.